Hi, welcome to Math After Hours with Miss Austin. I'm a licensed math teacher here to answer your math questions, and today we are looking at the binomial theorem. The binomial theorem is very closely related to Pascal's triangle. Usually when I teach these sections, I do both together. So if you need Pascal's triangle, I have a video for that as well. Otherwise, let's jump into the binomial theorem. So the binomial theorem is a way to find expansions like this without actually doing the multiplication. So I find this fascinating, but I'm the nerdy math teacher, so you know. So first, let's just look at some patterns here. If you raise anything to the 0 power, you get 1. If you raise anything to the first power, you just get that same thing back, a plus b. If you did a plus b squared, that's a plus b times a plus b. That's a squared plus 2ab plus b squared. A plus b cubed, so multiplying that out 3 times, we get this. A plus b to the 4th, we get this. So as we're looking through these things, are there any patterns? Well, if we're looking at a, let's look at a plus b cubed. The exponents on a go down by 1 each time. The first term has a cubed, second term a squared, then a to the 0. But a to the 0 is 1, which is why it doesn't show up here. And then your exponents on b increase. So we start with b to the 0, which is why it's not here because that's 1. Then b to the first, b squared, b cubed. And you'll find that same pattern on a plus b to the 4th. So the other thing that I notice is that within each term, the exponents will add to n. So for example, on this one, n is 4. So within each term, the exponent should add to 4. So this is just 4. On this one, we have 3 plus 1, which is 4. This one is 2 plus 2, which is 4. 1 plus 3, which is 4. And then 4 plus 0, technically. So using those patterns, as well as what I'll show you in a second to get the coefficients, you can expand anything. Okay, so this next part here, this looks confusing, but this is the binomial theorem. If you have a plus b to the nth power, you'll see this pattern of this exponent on a decreasing by 1 each time, and the exponent on b increasing each time. What you probably don't recognize is this right here. Unless you have taken probability or learned probability, you might think this looks familiar. So this is another way to get coefficients. So I was saying that I usually teach Pascal's triangle on the same day as this. Pascal's triangle is another way to get those coefficients, and this will do the exact same thing. So this is called a combination in probability, and you can find this on most calculators. So most calculators have a math menu. So for example, if you have the TI-84 calculator, you'll go into the math menu and then go over to probability. And then it's the option NCR. So that's how you would find this. So most scientific calculators will do this. You'll have a math menu and you can go find the probability to do this right here. So this is a combination and it means N choose R. So what you would do in your calculator is, let's just do an example. If you had 10 choose 7, and this is not a fraction, by the way. My students sometimes put a line right here, like it's a fraction is not a fraction. This is different notation. So this is saying 10 choose 7. How many ways are there to pick 7 things from 10? So in your calculator, you would first type in 10, and then you would follow those steps to get that NCR. And then once you get that, you'll do 7 and then enter, and you'll get 120. So that's how we do that. So like I said, this is just another way to find your coefficients. So if we jump into an example here, we have x plus y to the 4th. Now with binomial theorem, this top number in the notation is always n. And then the bottom number starts at 0 and goes up by 1. So that means here we would start with 4, choose 0, and then we'll follow the exponent pattern. X will start with the power of 4, y starts at 0, and then x will decrease by 1, y will increase by 1. So then we'll have 4 choose 1, x cubed, y to the 1st, then 4 choose 2, x squared, y squared, And then for choose 3, x to the first, y cubed. And then the last one, for choose 4, x to the 0, y to the fourth. So to find these coefficients, you would just type this in your calculator the same way we did above with this 10 choose 7. So when you do 4 choose 0, you get 1. So that means this would be 1 x to the fourth times 1, because that's what y to the 0 is. So your first term is just x to the fourth. When you do 4 choose 1, you get 4, and then we have x cubed y to the first. So the next term is just 4x cubed y. Then when you do 4 choose 2, you get 6. The next term would be 6x squared y squared. 4 choose 3 is 4, so we would have 4x y cubed. And then the last term, when you do 4 choose 4, that's 1. X to the 0 is 1, and then we have y to the fourth. So our last term is just y to the fourth. And that is the expansion of x plus y to the fourth power. So now I'm just going to show you one other example of this when we have other numbers in there. So this is 2x minus 1 to the fifth. So we're still going to follow the same pattern with the exponents and with the coefficients, but we have numbers in there. And that negative 1 is going to make it so the signs alternate. So to set this up, we have a 5 on top, and that will always be on top because that's our n in this case. And we start with 0. And then the first part of this is 2x. So we'll have 2x, that's starting to the power of 5. And then negative 1 starts with the power of 0. Then the next would be 5 choose 1. That bottom number goes up by 1. And then this is 2x to the fourth, negative 1 to the first. Then 5 choose 2, 2x cubed, negative 1 squared. 5 choose 3, 2x squared, negative 1 cubed. Then 5 choose 4, 2x to the first, negative 1 to the fourth. And then finally 5 choose 5, 2x to the 0, negative 1 to the fifth. So now we just need to simplify each term. So in your calculator, if you do 5 choose 0, you get 1. Then we have 2x to the fifth. So both 2 and x are raised to the fifth power. That's 32x to the fifth. And negative 1 to the 0 power is 1. So the first term is just 32x to the fifth. The next term, 5 choose 1, is 5. Then we have 2x to the fourth. 2 to the fourth is 16. Then we have x to the fourth. And then we're multiplying by a negative 1. So we have 5 times 16 times a negative 1. That's negative 80x to the fourth. And 5 choose 2 is 10. And then 2x cubed is 8x cubed. And then the negative 1 is squared, so that turns to a positive, and we get 80x cubed for that term from doing 10 times 8 times 1, x cubed. 5 choose 3 is 10. And then we have 2x squared, which is 4x squared. Then that's multiplied by a negative 1. So 10 times 4 times negative 1 is a negative 40x squared. And then 5 choose 4 is 5. Then we have times 2x times 1. So that is a plus 10x. And then our final term, 5 choose 5 is 1. 2x to the 0 is 1. And then negative 1 to the fifth is negative 1. So our expansion of 2x minus 1 to the fifth is 32x to the fifth minus 80x to the fourth plus 80x cubed minus 40x squared plus 10x minus 1. So that's how you use binomial theorem to expand. The other thing I wanted to go over is just how to find a specific coefficient or a specific term. Because as you can tell, that takes a while. So if you just want a specific term, you don't want to have to do the entire expansion to be able to find that. You want to be able to look for patterns and just find one single term. So let's say we want the coefficient of x to the sixth in the expansion of x plus 3 to the 8th? Well, looking at these terms above, whatever the exponent was always the number on top here. And then one thing we noticed at the very beginning is that these two numbers always add up to whatever n is. And then the other thing is look at these two numbers. They're always the same. So we can use that to just find one specific term. So I know that 8 is going to go on top because that's the exponent, and then I'm going to have x raised to some power, and then 3 raised to some power. But they tell me in the question that it's x to the 6th. If it's x to the 6th, this has to be a 6. And then what do we know about these two numbers? They always add to n, which in this case is 8. So this has to be a 2. And then the last thing we know is that these two numbers are always the same. And so this was a way to fill this in without doing the entire expansion. We can just put this part in the calculator and figure out the term. 8 choose 2 is 28. So this becomes 28 x to the 6th times 3 squared, which is 9. And then 28 x to the 6th times 9 is 252 x to the 6th. But let's go back to the question. It said find the coefficient of x to the 6th. Coefficient is just the number in front. So the answer would actually just be 252. And then our final example, this one says find the 5th term of 4b squared minus 3 to the 7th power. So I'm going to set this up. I know 7 is going to go on top because that's my n. Then we'll have 4b squared raised to some power, and then negative 3 raised to some power. This one's a little different. The last one, I told you it was x to the 6th. That immediately filled in one of those boxes, right? We knew it was going to be x to the 6th. All this one says is find the 5th term. So let's go back up here and look at a pattern. Okay, this is the first term. This right here is a 0. This is the second term, that's a 1. The third term, that's a 2. So it's always 1 less, which means if it's the 5th term, this is a 4. So this is also a 4 because those two numbers are the same, and then these two add to n. So if they add to 7, the last one is a 3. So we can plug this in the calculator. We will do 7 choose 4, which is 35. Then we have 4b squared cubed. So 4 cubed is 64. And then when you have a power to a power, you multiply. So this will actually become b to the 6th. And then we have the negative 3 to the 4th, which is 81. So if we do 35 times 64 times 81, that's 181,440 b to the 6th, and that is the 5th term of that expansion. Okay, I hope that was helpful for you. I really like the binomial theorem, and I actually really like Pascal's triangle, which again, I do have a video for that if you want to go through Pascal's triangle. I actually like Pascal's triangle a little bit better if the exponents are smaller for finding the coefficients, but that's just me. If you have any questions you would like me to do, please comment them below, and please like and subscribe.